Hey, good morning, everyone. Thank you for coming to this talk, last talk before lunch. My name is Alexei Kojenov, and I'm going to be talking about deserialization today. A little bit about me. I'm a software developer in the past, and then at some point I realized that breaking code was way more interesting than writing code, and I moved to the security side and have been doing that ever since. But still, deep inside, I think I'm a developer. So today's talk is going to be mostly looking at the code, running it, and seeing what's happening. So those people in the back, I don't know, you might want to move a little bit closer. I tried to make the font bigger in my demo. We're going to be talking about what deserialization is, how it's used, why it can be dangerous, and we're going to talk about a few vulnerabilities. So imagine you have a program with some kind of object in this program, in the memory, and that program wants to send that object to another process or another program. And the way it's usually done, that object is converted to some kind of byte stream, and that byte stream goes over a communication channel, which could be a network or even a disk or some kind of API call. And on the other end, that byte stream is converted back to internal representation of the object in another program. And these two processes are called serialization and deserialization. This is a very easy concept. There are languages that support native serialization, and some of them use binary formats, for example, Java, or even if you just snap a memory that is allocated by a C++ object, that you can tell that this is a serialized object. And we also have some human-readable formats, for example, XML or JSON. These are basically text files which you can open and read and understand exactly what's in it. There are tags and some data between those tags or some other kind of characters that tell you what the data is and how you can interpret it. All right, and with that, we move into our lab. And let's take a look at some basic serialization stuff. I hope you can see it okay. I made the font large enough. So we have a class called Planet. And this class implements java.io.serializable, which means that this class, the objects of this class could be serialized and deserialized. Planet has order in the solar system, name, nickname, and mass. And not much else. And we have a class called basic serialize, which just has the main method. And first thing it does, it creates an instance of a planet. And we created a planet for Earth. And it's going to serialize that object and write it to a file called earth.ser. And the way serialization is done in Java is you create object output stream, and you call its method called writeObject. And you can feed any Java object to it, and it will just serialize it. And since we write it to a file, we also have our file output stream. And as soon as we write our object to a file, we're going to read from it. And we're going to use our object input stream and deserialize that object by calling the readObject method. And this method deserializes the byte stream and returns just a plain Java object, and we need to cast it to the class that we are dealing with, which is Planet. So enough theory, let's run it. I'm compiling my code. Hope it works. Yeah, so I ran the code, and it told me that object was written to earth.ser, and then we read it, and we printed that planet right here. Okay? If I look at the disk, I have this file. So let's take a look at this file a little closer. First of all, I'm going to use Linux utility called file, which analyzes file and tells me what it is. And in this case, it tells me this is Java serialization data version 5. OK, pretty good. Now, let's take a look at the hex data. And I'm going to use I think that's the right syntax. Hold on a second, sorry about that. I need to make this window a little smaller so everything fits on the screen. Okay. This is the hex data for that serialized Java object. And the first 4 bytes read ACED0005. If you see this kind of signature somewhere, you can guess that this is serialized Java data. That's useful to know. On the right-hand side, the raw data. And even though it's not necessarily text, it's not really readable, but you can see pieces of information here, like planet, which is our class name, or the member names, like nickname, and even the date itself, Earth and blue planet. Cool. Let's also try to base 64 encode this data. And this is completely unreadable, but the first 5 characters read RO0AB. If you see this kind of signature somewhere, like in your burp log, for example, you can guess with high probability that this is serialized Java data. Okay. And we move into our second exercise, and we're going to use serialized object for authentication. Let me clean this up a little bit. We have a different class here. It's called user, and it also implements java.io.serializable, which, as we know, this object can be serialized and deserialized. And user has a username and role, and has a little method called isAdmin, which returns true if the role equals administrator. We also have our session manager, our session class. And this class has 2 constructors. The first constructor accepts username and password and authenticates the user with these credentials. And then it returns the session cookie based on that. And our session cookie is just serialized user object. And also has a second constructor. And this one accepts cookie and performs the opposite thing. It deserializes this cookie, gets the user object out of it, and then welcomes the user back, and determines whether the user is administrator. So let's see what happens when we run it. I'm going to pretend that I'm typing this in a web interface. This is just a unit test command line, right? So before I do that, let me jump back to the code and show you my user database. We have 2 users, Copernicus, who is a regular user, and Galileo, who is administrator, so 2 astronomers. We also have a couple of classes to serialize and deserialize, pretty much the same stuff that we saw before, except this time we deal with base 64 data, not just binary stuff. Okay. So I'm authenticating as Copernicus first. His password is Poland. And I authenticate successfully and got this session cookie. Now, my browser on the next HTTP request is going to submit the session cookie to the web application and try to do something. So let's try and see how it works. I submitted my session cookie to the session manager, and it welcomed me back as Copernicus. Great. So let's do the same thing for our administrative user. His password is Italy. Here's my session cookie. I'm going to copy it again and give it back to the application. He welcomed me as Galileo and told me that I'm administrator. Makes sense, right? Pretty straightforward. Now, let us take a closer look at Copernicus cookie, who is non-admin, and see what we can do to fix that. I'm going to print this cookie, and I'm going to base64 decode it and write it to a file called cookie.ser. Okay, now we have this file on the disk. And I'm running a hex editor. And this is similar to what we saw before, right? And if I analyze it a little bit, I can find this, the string which reads regular. So I'm just going to go ahead and replace it with administrator and see what happens. So I'm going to start typing admin is, and I ran out of room here because administrator is obviously longer. So I need to go to insert mode. And since this is a longer string, I also need to fix this byte here, which is basically the length of the string. So I'm going to change it to 0D. Save it, close it. And what I'm going to do now is I have my new cookie in this file, so I'm going to base64 encode it. I need to use this parameter so it doesn't break the string. And I'm going to feed it to my session manager. So now it welcomed me back as Copernicus, but this time it told me that I'm administrator, right? So I was able to modify that serialized data and replace a very critical thing with my own stuff. And the reason I was able to do it was because the session manager does not check the integrity of this cookie. It just accepts it as it's true and interprets it and just uses it and makes decision based on it. So if my session manager was using a private key to sign this message and check it when it receives the cookie, this could not be possible. Okay. So far, so good. And we're moving into our third exercise. This time, we're going to use serialized object and upload it to our application, and it should accept it and do something with it. We have our planet object, the same one that we saw in lab number 1. And we have upload manager. And this is a simple program. It just parses the standard input, and it's looking for this little string, RO0AB, which, as we know now, is a signature for serialized Java data. And as soon as it sees something like this, it's going to call a method called process upload. And this method basically deserializes that stuff and creates planet object out of it, and then we need to do something with this planet. We have not implemented it yet. Like, for example, we want to store it in our solar system database. So we let astronomers upload new planets to our wonderful web application. And in order to get some sample data, I wrote a little program that generates several planets, Mercury, Venus, and Earth. It serializes them. And I also serialize a string. So this is just a simple string object. And the reason I do it is I just want to see what's happening when my back-end code is seeing a string, which should not be there. So I compiled this sample object generator, and here are the 3 planets and a string, a little string here. Now I need to compile my upload manager. And now what I'm going to do is I'm just going to pipe output of my serial generator with which is basically this whole stuff right here, to my upload manager, and it should process all these things one by one. And it did. It told me that Mercury, Venus, and Earth were successfully uploaded, and then it got an exception because it saw a string, which is nice, right? And as long as we handle this exception correctly, we should be okay. We will not process the string, and will not fail completely. But I want you to pay attention to the exact error message here, which says, string cannot be cast to planet, which suggests that this method, readObject, did actually return. So the object was deserialized. That string was deserialized. The error, the exception was thrown here when we tried to cast it to planet, because string and planet are not compatible. You cannot cast one to another. Okay, in order to prove my point that deserialization happens no matter what, I have more stuff in my sample object generator, some bad stuff here, some kind of bad object. So I uncommented this, and I need to recompile my serial generator, and I'm going to run the code again. Okay? And again, it processed the 3 planets. It got an exception on the string, right? This is part of it. And then it did not return. And it sits here, not giving me back my command line. And if I look at my task manager, it tells me that this process, the upload manager, consumes 100% of my CPU, actually over 100. I don't know how it's possible, but must be some really bad stuff. And trust me, it's going to sit here forever. It's never going to return. So I'm just going to kill it. So I killed it. I got back my command line. And let's take a look at that object. And here it is. I didn't write it. Full disclosure, I just got it off OWASP website. And this object is basically a hash set, which has more hash sets. So it's a kind of a structure, maybe a tree. So we iterate 100 times, and we create new hash sets and add some data to them, and then set those links, you know. And this is not a huge object, right? We iterate only 100 times, but JVM has a big issue with it. It does not like it. When it tries to deserialize it and build that graph, it just never finishes. So this is a great way to kill your application, to make it use CPU cycles. And the more we submit, stuff like that, we can just disable the application. Yeah, so this code consumes CPU indefinitely when deserialized. What about this? This is a very small object. So this one would actually try to allocate 8 gigabytes of heap. Sweet. What about this one? It's still a pretty small object. So this one will try to allocate 64 gigabytes. There's just 2 different methods to do it. So, and you can imagine that stuff like that can kill your application. It will just say, I'm done. I have a few examples of that. If you look up this name online, and I have some links at the end, you'll see more examples. So this guy just writes this for fun. So yeah, this is the serialized object that will cause my program to allocate 64 gig. If I give it to my upload manager, I don't have 64 gig on this little VM. It instantly ran out of space, and it didn't fail gracefully. It just finished. So I killed it. Awesome. Okay. Denial of service. So how can we protect from this kind of stuff? How can we prevent this unsafe deserialization? And one way to do it in Java, bear with me for a moment. I should have not closed this, but okay. Remember this object input stream. This is the standard class that is used for deserialization. We can extend it, and we're going to call it safe object input stream. And the only thing that we're going to do this time is to override one of the classes. This class is called resolve class. One of the methods. This method is called resolve class. This method is called during deserialization automatically. And what we're going to do here is we get the class name from the input that we are deserializing, and we're going to compare it to the class name of the class that we expect to see, which is the planet. And if one does not equal to the other, we're just going to throw a custom exception, and we should fail gracefully. Make sense, right? You know,